Okay, welcome. This is another short little, maybe 10-minute, one pass video. Let's see how we do. This one is to introduce a classic method in SAT prep. This is not one that I invented. This one's been around forever. It's a method that takes what looks like an algebra problem and turns it back into an arithmetic problem. I call it the backdoor play because at the end of it, in my mind, what you get is an easy layup. But it doesn't matter what it's called. What matters is that you recognize it and you take the opportunity to use it. I will say this comes up 3 or 4 times in just about every SAT. So let's just jump right on in and I'll show you what I'm talking about. Here's a problem that looks like an SAT algebra problem. And something I want you to be ready for is when you look at a problem like this, if you see variables in the question, this one has n, and variables in the answer choices, oh, look, a whole bunch of n's, it's a good idea to try making up numbers that fit the variables and then do the problem that way. And I'm just going to show you what I mean. Okay, I see an n in the question. I see n's in the answer. Even this phrase here, in terms of n, warns me that, oh, the answer choices are algebra, but we're not going to do it that way. Here's what we're going to do. We're going to make up a number. And when you make up your number, write it down. But we can't just make up any old number. We have to pick a number between 0 and 10. You also want to get in a habit of trying to pick a nice, easy number, but maybe not the most obvious number. And I'll tell you why in a bit. So for example, I bet a lot of people say, well, halfway between 0 and 10 is 5. 5 would be fine, but just to be slightly different, I'm going to use 4. So I'm going to say to myself, n equals 4. And I don't just write down 4, I write down n equals 4, because otherwise later in the process, I might forget what I did. Okay, now you just read the question again, but you do it based on your made up number. All right, this club has 50 students as members. Let's see. There are 20 of them who are seniors. Okay, I can keep track of that. They say n are juniors, but wait a minute, I'm using 4, so I've got 4 juniors. 2 n sophomores, so for me, that's 8 sophomores. And the rest are freshmen. Well, wait a minute. They told me that there are 50 overall. We can figure out how many freshmen there are. Let's figure out how many freshmen there are. 20 and 4 is 24 and 8. 24 and 8 is 32. That leaves us 18 freshmen. Okay, but oh, wait a minute. That's not what they asked. They say, what percent of the members are freshmen? So you could do 18 divided by 50 and then multiply it by 100, or you could just notice, you could also do 18 over 50 is x over 100, or you could just notice, hey, wait a minute, 50 is half of 100. If I just double 18, however you do it, you get 36%. And that is your answer. It isn't everybody's answer. Everybody who makes up a different number for n might get a different answer. But for you who used n equals 4, n equals 4 takes us to the answer 36%. Now, when you first look at the answer choices, you don't see 36% because all the answers have n's in them. That's why we wanted to be careful to write down what we used for n. We're going to plug that same n into each answer choice and see what we get. And if it isn't 36, it's wrong. Let's see. 7 times 4 is 28. That's not 36. 3 minus 4 is 12. 30 minus 12. 30 minus 12 is 18, but more importantly, it's not 36. Hey, how about this one? 50 minus 12. Oh, that's 38. Oh, that's close, but still not 36. And then when you do 60 minus 6 times 4 is 24. Aha, there's your winner. That's the answer. These 3 are clearly wrong, and we're done. The answer is D. Okay. Now, when I teach this, almost always somebody asks, yeah, but how did you know to use n equals 4 in the first place? I didn't, and it doesn't matter. Try it again yourself right now using n equals 7 or whatever you want. You won't get 36 as your answer, but when you get to the last step where you plug your n values into each answer choice, it will rule out all but one of them. Now, I am going to show you one more example of this, but first I do want to mention, sometimes when you are unlucky, instead of getting all 4 answers and 3 ruled out and 1 right, you sometimes get more than one that matches. That's not the end of the world. It just means you're going to have to go back and try it again with a different number. That's why I encourage kids to choose numbers that are slightly off the beaten path, just slightly different than what everybody else will use, because it makes it happen less often. But when it does happen, it's not a big deal. Just try a different number. Okay, let's do another one. If p plus r plus 1 equals n squared, which of the following is the average of p and r? Now, if you're good at algebra, you can look at this and come up with an algebraic way to get the answer pretty quickly. But what if you just don't think of that? I still see variables in the question. I see variables in the answers. I'm going to make up numbers, but this time I have to make up numbers for all three variables. There's a p, an r, and an n. I have to make up all three of them. And I have to make up numbers that fit the problem. This is a little harder than last time. Last time we just had to pick an n. Now we've got to come up with numbers that make this true. For example, you might be tempted to say, oh, I'll use, how about 1, 2, and 3. I'll let p equal 1, r equal 2, and n equal 3. But wait a minute. When you go to check that, when you do 1 plus 2 plus 1, you get 4. When you do 3 squared, you get 9. That doesn't work. They're not equal. You cannot use 1, 2, and 3. Okay, you got to start again. Don't let it bother you. Sometimes it takes a few seconds or even a minute to come up with numbers that work. But once you do, you'll see the rest of the problem is easy. So here I am still trying to come up with numbers that make p plus r plus 1 equals n squared. I guess if you want, you could pause the video and come up with your own. Eventually, you're going to think of, hey, wait a minute, why don't we make up n first? Let's say we let n equal 5. Well, then n squared is 25. And now I just have to make these numbers add up to 25. Well, I already have 1. I need 24. How about 20 for p and 4 for r? So those are going to be my numbers. My numbers are going to be 20 for p, 4 for r, and 5 for n. And if you look, that really does work. 20 plus 4 plus 1 is 25, and 5 squared is 25. These are good numbers. They fit the problem. Okay, now what? Wait, what do they want to know? They want the average of p and r. So I know how to find the average of two numbers. I do p plus r over 2, but I use my numbers that I've just made up to fit the problem. Okay, so for us, that's going to be 20 plus 4 divided by 2. And I get 24 over 2, and my answer is 12. And I look at the answer choices, and I don't see a 12. Oh, that's right. They all have n's in them. I have to remember what I used for n. Oh, good thing I wrote it down here. I'm going to take n equals 5, and I'm going to plug it in to all 4 answer choices, hoping that only one of them turns out to match our answer, which was 12. Let's see. I'll walk you backwards. If I start with D, 5 minus 1 is 4. 4 squared is 16 divided by 2 is 8, and that's not 12. How about here? 5 squared is 25 times 2 is 50 minus 1 is definitely not 12. How about this one? 5 squared is 25 plus 1 is 26 over 2 is 13. Again, close but not right. Boy, I really hope A works, and of course it's going to. 5 plus 1 is 6. 5 minus 1 is 4. 6 times 4 is 24 over 2 is 12, and there's your winner. Practice this method. I'm telling you, you can go through all the released SATs, go through practice SATs 1 through 10, and whatever else you find. Every one of them, you'll find 3 or 4 problems where you can avoid the algebra by making up numbers that fit, and then plug into the answer choices as well to get the easy layup.